So our next question is list the different data types used in C++. Give example for each data type. So let us list the data types used in C++. Now broadly, the C++ data types can be defined into three different types. So the center one, which you can call it as a built-in type, or you can call it as a basic data type, or you can call it as a standard data type. So this is the built-in, which is already directly the basic data type available in the language compiler. So you have in the basic or built-in or standard data type, you have something like integers or integral types. Then you have a void type and you have a float type. Then you have other one is a user-defined data type and a derived data type. Now let us first look at the derived data type. So let us go next to our slide and we will come to know here more in detail. So you see here in derived data type you have arrays, functions, pointers and references. We'll get into the detail, we'll understand them in more detail going forward in the next few slides. And the third one you have is a user-defined types, like a structure, union, you just saw a class, and enumeration data types. So let us look at the built-in type or a basic data type or a standard data type first. So this standard or built-in or basic data types are data types for which the programming language provides built-in support. The data type are provided by C++ compiler as basic building blocks. It is used to handle only one value at a time by using single definition. So if you have an integer, you can store one integer. If you have one float, if you have a float, so integer I means you can store some value like 10, 20 in the integer I. You can store any value, but you can store only one value in the integer I. If you have a float f, then the f can have any value with a decimal point, but only one value. The void data type is basically, it's an empty argument. So if at all you don't want to return anything from the function, you will use a void data type. If you want an integer to return from the function, you will use int the function name. Void and function name means the function is not going to return anything. If you have any other like a string and the function name, it is going to return a string basically. The next one is the derived or extended data type. Now these derived data types are used to extend the behavior of the existing simple data type. These are also built into the system, so it's of the same type basically. The data type is of the same type. So derived data type are used to extend the behavior of an existing simple data type to get more functionality. It is used to handle more than one value at a time using a single identifier. The various derived data type provided by C++ are arrays. Then you have functions, references and pointers. Now array is the set of element of a same data type. So like if you have an array of integer, then you can have a set of integers. So if you have an array of 10 dimensions of 10 subscripts basically, then it can hold a 10 values from 10 different values of integer if it is integer data type. All elements in arrays are stored in a continuous memory locations, and each element is accessed by a unique index. So every array value can be accessed by an index value, like array of 0, an array of 1, or array of 2, and array of 3, etc. So the subscript index, which is called as a subscript, the subscript value indicates the position of the element in the array. The second derived data type is function. Function is a self-contained program segment that carries out a specific well-defined task. So you have some particular well-defined task, then you would want that task to be separately, so you want that program to do that task. So it is a self-contained program segment that carries out a specific well-defined task. In C++, every program contains one or more functions which can be invoked from other part of the program. The third one is a reference data type. In a reference data type, is an alias for a variable in a program. So it's something like you are telling, okay, you have an integer I and you have integer j which is referring to I. So if j is referring to I, then if I value keeps on changing, j value is automatically changing because it's just referring to I. And if j's value is changed, the I value is also changed because j is referring to I. So actually whenever value is changing, it's actually going and changing the value of I. So that is what is the reference data type. And the next one is a pointer. A pointer is a variable that can store the memory address of the another variable. So it stores the memory address of another variable. Pointer allows to use the memory dynamically. So we will get into these details more in coming slides. So I hope you have understood this derived data types. The next one is a user-defined data types. Various user-defined data types provided by C++ are structures, unions, enumerations, and classes. Structures, unions, and classes provide a way to group a similar or dissimilar data type referred to by a single name. So you've already seen this in a class. I will show you in more structure and union also, and I will show you how they differ basically. Next is enumeration data type. A enumeration data type is a set of named integer constant that specify all the permissible values that can be assigned to a enumeration variable. These set of permissible values are known as enumerators. For example, consider the statement enum country. So the country variable can have UK, USA, France, India, and China. It has all these. So only these you want to enumerate. Then you can use an enumeration data type. I'll show you with an example so you will understand in greater details. So let me show you one example for structures unions first. So you have a structure in union. So this is, if you look at this program, you will understand. So we have declared a union here, and then we have declared a structure. This union is similar to the class that you would have seen, but it doesn't have an access specifier, and it is you have three variables declared inside the union. The same three variables are declared inside a structure. Now the difference between the union and the structure is, if you look at them, you may be able to see that they are almost the same, except this particular union and the structure. Except this particular change, everything else is same. Now what is the difference between them is, whenever you declare a structure, the compiler makes space for three data types. Basically you have declared character array of 16 bytes, that is 16 characters. Then you have declared one float, salary, and then you have declared one integer, that is worker number. So the same thing you have declared for union. For union also it is declared the same. So we have declared character array name of 16 bytes or 16 characters, and then you have a float which is a salary which is of float type, and a worker number which is of an integer type. Now in union, what it actually does is it will find out what is the highest, which is a variable which wants the highest space. So here it's character name which is of 16 bytes basically, or 16 characters. The float wants 4 bytes and the integer wants 4 bytes. So the union will actually allocate 16 bytes of space, and it will allow you to store only one of these variables, not all of them. Whereas in a structure, you can actually access store value for all 3 of them, because it allocates space 16 plus 8, 4 plus 4, that is 24 bytes of space. Now, I've written a program just to understand what is the size it is actually doing. So here you can see out size of union, and I'm just writing size of, that is U job, that is union job, and this is structure job, then size of S job. Now let us run this program and check. So I will compile this and execute it. Now you can see exactly as I told you, the size of union is 16 bytes because that's the maximum size you can have in a, so whatever is the maximum variable, that is the size it allocates. Whereas for a structure, it is allocated 24 bytes. So I hope it's very clear, like the difference between the union and the structure. Now I will make some dynamic changes and make you understand. Example, you have a union of this particular structure. So what you do, what if we have something like I'm declaring to my union data type here. And let's compile this now. Sorry. So it's compiled. So in spite of declaring, it's still giving only 16 bytes of space. So what it exactly means is you have 3 unions actually. You have one is this one, then you have another union job 1, then you have another union job 2. But out of this is a union and this is a union, and these are all, it takes each one of them as a different data type, and it will allocate only 16 bytes of space. Now instead of union, if you have a structure, now what will happen in that case? So if the same thing, if we do it in the structure, okay. I'm compiling it, build it, and execute this. Now you see the size of the structure has become 72. So I am very sure it is very clear to you how this structures and unions are working. Now let us see how the class is different from this. So I've deleted the extra thing. If you declare in place of structure, if you declare it as just a class, okay, and instead of this I'll just change the union as a class, okay, and let us this call this, okay, and let us compile this. Okay, something is left over from, okay, it sounds successfully compiled. So you can see now we should have changed this. This is actually the class data, and it is actually the same 24 bytes. So the size of the class is 24, the size of the structure is also 24. Then how they are different? Now if I want to access, I want to store a value into I want to use a value. So if I try to use this and I tell okay, something like cout, okay, and just tell worker number is equal to 10, and then if I actually print that, so I can actually print this one. So it's compiled, execute, sorry, I didn't build it, so I'm building it and execute. So now you can see the structure worker number is equal to 10. So that's the value what we have stored. In the same place, now this is called as uJob, okay, which is a class basically. If I try to store the same, instead of if I try to store value into uJobs, what is going to happen? Compilation failed. So why the compilation has failed? Let us look into that. So you can see here, so in union jobs, okay, we just didn't change the name. This is actually a class now, union job. In union job, the worker number is private. So this is actually a private. So the difference between the structure and the class is, by default, all of this is public, whereas by default in class, all the data members are private. So if you actually just make it public, then they are both same. Yes, we have compiled successfully. So we can actually print the value of the class also. So you can see that class worker number is 20. So we are able to store the value into the class. So I hope you have understood very clearly the difference between the structure, class and the union. So let us go back to our program. So next is the enumeration data type. A enumeration is a set of named integers, constants, that specify all permissible values. Now, I'll show you through an example basically the enumeration data type. So we have an example here and we have declared a enum called week. And the week actually starts with, you have not declared anything. Okay, so you have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. And then you tell then you tell day is equal to, you have declared the enum type week and you have declared one day, and then you tell day is equal to Thursday. What you are doing next is you are printing that particular day. This is not going to be that. This is required now. Compile, build and execute. So now you see what has happened. Because it's Thursday, so automatically the value of Sunday is 0, 1, 2, 3 and 4. So you told day is equal to Thursday, and we are actually trying to print the value of the day which we have assigned as a Thursday, and it is giving weekday number is equal to 4. Now in case you want to change the order, or you want to make it something like you want to start it from 1, so Sunday 1, so then what is going to happen? Now you can see the weekday, because by default it starts with 0. The first value is taken as a 0. But if you give first value as 1, then subsequent values it increments 1 by 1. So the enum for Thursday becomes 5. So weekday number is 5. Now what would happen in case if I give the next value as as 10, and I give something like this one. So then it is 20. If Tuesday is 20, 21, 22 is going to be the value of Thursday. So you see, weekday value is 22. Now in case if you want to do something like this, you want to add the value of Thursday and Sunday. So what is going to happen? Now what is the value of 22 is the value of Thursday. And if you add 1 to that, it is going to be 23. So let us see whether it is going to be, so we will have to declare the variable I, integer I, and then we will have to print the variable I. So let us check. So you can see the value of Thursday plus Sunday is 23. So I hope this example was good and you were able to understand the enumeration data type. Thank you, viewers. If you have enjoyed learning, then please like, share and subscribe our channel. Thank you.